Today we're looking at lesson 10.1 for algebra on square root functions. As we were looking at with the exponential functions, the square root functions also have a parent function or the most basic function, and the criteria for that would look like this top one. And it says it's f of x equals the square root of x. So if you think about when we were doing linear functions, when we had f of x equals x, that was the most basic you can get. That's kind of like what this is. So to graph it, we're still going to make a table. If we do have the function in this form, the domain is always going to be x is greater than or equal to 0. And the range is always going to be y is greater than or equal to 0. But if we adjust it, or if we translate it in any way, then the domain and range could possibly change. So the first thing we did here is we're graphing this function, g of x equals 4 times the square root of x. So we're going to plug in each value for x into the square root of x, and we're going to find the values. So if I plug in 0 for the square root of x, the square root of 0 is 0. So that is multiplied by 4, which also will give me 0. The number 1, if I put in the square root of 1, that's going to be 1. And if I multiply that by 4, then I get 4. And then the square root of 2 is a decimal, and if I multiply that by 4, I would get about 5.7. So these are the ordered pairs that I'm going to graph. So on the next page, that's what I've done here, is I've graphed it. And since it's in the form of the most basic function, where we have the square root of x times any kind of number, but we don't have an addition or a subtraction of anything, then the domain is going to be x is greater than or equal to 0, and the range is also going to be greater than or equal to 0. Because if you also think of this in a different way, we'll address this more when you get into Algebra 2, but if you put in a negative number, you don't have, at this point we know that you can't have the square root of a negative number. It's going to be an imaginary number. So we can't go lower with our values of x than 0. So we're always going to use for our tables here 0, 1, and 2. Now the next one I've also done. This just changes it to be 6 times the square root of x, so the numbers are a little bit different. But notice it's still 0, 0, and then the square root of 1 is always 1, so 1 times 6 is 6, and the square root of 2 is a decimal. Multiply that by 6, it's about 8.5. And again, we have something similar to what we just did, and the domain is going to be x is greater than or equal to 0, and the range is always going to be y is greater than or equal to 0. Then we move on to translating it, and I've pointed this out a little bit because we're going to be also comparing these graphs using some new type of language to the parent graph. So sometimes we can actually, add or subtract to the square root. Sometimes we multiply, which we just did. And then sometimes we add or subtract from the square root inside the square root symbol. So there's 3 different things that we can do to adjust it. And we're going to do a couple of different examples there. Notice that when you add or subtract and it's underneath the square root symbol, as in this h plus h, it's going to move your graph left or right. If you're adding a number greater than 0, it's going to move it towards the left. If you subtract a number if you subtract a number, it's going to move it to the right. And then if you have a number outside the square root, like the k, where you're adding it, it's going to move it up, the graph's up. And if you're subtracting the k outside the square root, then it's going to move the graph down. And you can just see that when you graph it. You don't actually have to really remember that, but we'll do a few examples where you can see it move. So this one, they have multiplied it by a negative number. So we're going to compare that to the graph of what we just did, the first two. And we're going to make our table. We're going to use values greater than 0 or 0 or greater, because we're dealing with square roots. So 0, 1, and 2. We're going to plug in square root of 0 is 0 times negative 2 is 0. So that's still the starting point. Square root of 1 is 1, but 1 times negative 2 is negative 2. So that's going to move it so that it's underneath the x-axis. And then the square root of 2 is a decimal, and multiply that by negative 2. And that gives me a decimal of about negative 2.8. So I'm going to graph these on my graph. Put a point at 0, 0. Add a point at 1, negative 2. And a point at 2, negative 2.8. So my curve then is going to look like this. So notice what it did to the graph. In the beginning, my graphs were above the x-axis here. Now they're below the x-axis, so if I'm going to do the domain, my domain is still going to start at 0, and it looks like it's going to stay as greater than or equal to 0 because we're on the right side of the graph, and we can't go past 0 when we have square roots. So that stays the same, but the range, the range is starting at 0 but continuing to go down. So it is actually going to be less than or equal to 0. Now, if I were to use words to compare this to the parent graph, I need to think about, okay, how would I compare it? Well, I know that it's below the x-axis now. So what we use to compare, or the words that we use to compare those types of graphs are that it's reflected across the x-axis. So I'm going to say that. And it also is stretched vertically. Now the other ones were actually stretched vertically as well, these, because we multiplied the parent graph by a number other than 1, so it does make it a little bit stretched. So if I wanted to compare this to the parent graph, I would also say stretched vertically, but that's all I would say. With the one I just did, I would say that it's stretched vertically, but it's also reflected across the x-axis. The next one is actually very similar to this one. So I'm going to skip that one and do one that's a little bit different, because this would also be stretched across the, or reflected across the x-axis, and it would also have the same domain and range, and it would be considered stretched vertically. It would just be a little bit different numbers. This one, notice this one has the parent graph, but then it is subtracting by 4 outside of the square root. So we're going to see what that does to the graph. So it doesn't seem like it's going to be stretched, but it will be considered translated. So we'll talk about that in a second. So we're going to put in 0 for the square root, and 0, the square root of 0 is 0, minus 4 is negative 4, square root of 1 is 1, 1 minus 4 is negative 3, and then the square root of 2 is a decimal, so that's going to be about 1.4 minus 4, which gives me about negative 2.6. So if I graph these, I'm going to have a point at 0, negative 4. I'm going to have a point at 1, negative 3, and a point at 2, negative 2.6. So it's doing a slight curve. Oops. I don't want to go past the axis. So it's going to do a slight curve like that. It's going to keep going like this. And so if I were to describe this here, I would say it's not stretched because I didn't do anything by multiplying the parent function times a number, but it is translated. So we'd say that if I'm comparing this to the parent function, it's translated down 4 units because most of the parent, or all of the parent functions started at 0, and this does not start at 0. It starts at negative 4. Our domain is still, though, going to be x is greater than or equal to 0 because we're not going past the y-axis here, and we're going to keep it as positive values of x, which I talked about in the beginning. We need to always keep it as positive values of x because we're taking the square root of x. And then the range changes a bit because we're starting at negative 4, and we're going to be going up. So that's going to be y is greater than or equal to negative 4. This one is going to be a little bit different still. This one has the plus 3 underneath the square root symbol. So that's going to be not translated up or down. It's going to be translated to the left or right. So we'll see which direction here that is. So this is going to be 0 plus 3, so it's the square root of 3. Which is about 1.7. And then the square root of 4, which is 2. And then the square root of 5, which would be about 2.2. So we're going to graph these. So I have 0, 1.7, 1, 2, and 2, 2.2. So that is going to be going like this. So this one, it starts, again, it's always never going to go past the y-axis, so our domain is going to be still x is greater than or equal to 0. Oh, I'm sorry. Okay, so I meant to say that this one, remember how I've always said that you can't go past the square root of 0, so you can't get any lower than the square root of 0 at this point. So actually what we need to think about is what would give me the square root of 0. So in this case only, when I have something that's translated and the number is underneath the square root symbol, I can actually go as low as whatever would give me the square root of 0. which would make x be able to go lower than 0 this time, we could actually start, and this is what I would do to get a better picture. I'd start at -3. So -3, -2, -1, something like that, and go all the way up to 0. And that would give me a better picture, because -3 plus 3 is 0, so the square root of 0 is 0. So that tells me where it's actually going to start. Then you have -2 plus 3 is 1, square root of 1 is 1. Then we can do -1 plus 3, that's the square root of 2, which we've done a bunch of times. The square root of 2 is going to be about 1.4. So that's going to go here. So this is 1.4. And then 0 plus 3 is 3. The square root of 3 is going to be about 1.7. So that would be a little bit different than the rest of these, because we can start below x is 0, because the translation is underneath the square root symbol. So you can actually start your graph here, -3, 0, and then continue -2, 1, and then -1, 1.4, and then 0, 1.7. So it's going to look a little bit like this. So this time the domain does change, and it's going to be x is not greater than or equal to 0, but greater than or equal to -3, because we can go a little bit further down and still have the square root of 0. And then your domain is going to stay as y is greater than or equal to 0, because we're not going to go below the x-axis here. And then you would say, if I'm comparing this, notice that it's to the left 3 units, so this is going to be translated left 3 units from where the parent graph starts. The next one is a couple different translations. Now there's an example in the book where it asks us to predict using the square root function. This is actually similar to when we were using our calculators to predict. With linear functions, we would just put the function into y equals. It would just be a square root function instead, and we'd do the same steps to predict. We're going to skip that example, because you could also just plug in values of the variables and solve it that way, and you wouldn't need to use this calculator, but it would take the same steps as what we've done before. So we're going to move on to a little bit more translating or transformations, which is going to be involving more than one translation, and we'll see what these do to the graphs, and then compare it to the parent graphs and talk about the domain and range. So in this case, we need to think about what we can start with. We have the square root of x times 1/2, and then -1 after that. So we're going to have to start with 0 to keep it as the square root of 0 as the lowest we go. So we'll do 0, 1, 2 again. And that will plug in as the square root of 0 is 0 times 1/2 is 0, and 0 minus 1 is -1. Square root of 1 is 1 times 1/2 is 1/2, and then 1/2 minus 1 is -1/2. Then the square root of 2 is 1.4. 1.4 times 1/2 is about 0.7. 0.7 minus 1 is going to give me -0.3. So I'm going to graph these. So I have 0, negative 1. I have 1, negative 1/2. And I have 2, negative 0.3. If I have kept going here, I am allowed to cross the x-axis, which is unlike when we were doing exponential functions, because in this case we can keep going with our numbers, and we'd still get numbers that are greater than 0. So that's allowed if we're taking the square root of them. So this would cross the x-axis just slightly with the curve. Our comparison would be that, notice that it's actually shrinking, so it's a little bit smaller each time. So I would say that this is not stretched vertically, but it's compressed vertically, because the numbers are getting smaller for y. And then our domain is still going to be starting at 0, 0, because it starts, or not 0, 0, at 0 because it doesn't go past the y-axis. We can't get any lower than x is 0. Our range is going to be starting at our y-intercept and going from there. And it can be anything greater than or equal to negative 1. So that's how we would compare it. It's also translated down 1. So we could also write that. And then the next one, we'll do one more. This would be thinking of numbers that are no less than x's, or the square root of x is 0. Which number could we start with? We could start with 1. So we're going to start with 1. And then we can keep going up. So 1, 2, and 3. So if we have 1 minus 1, that's the square root of 0. 0 times negative 2 is 0. Then we have 2 minus 1 is 1. Square root of 1 is 1 times negative 2 is negative 2. Then we have 3 minus 1, which is the square root of 2. So 1.4 times negative 2. Equals about negative, whoops, equals about negative 2.8. So we're going to graph these, and we can keep going as long as we stay with our square root above 0. So we could keep going this way, but we're going to stop, just we don't need that many points. We're going to put in 1, 0, and then 2, negative 2, and then 3, negative 2.8. This we're going to say is, sorry, that's my son. So for this one, this is going to be considered stretched vertically. And really you can tell by what it's being multiplied by. Remember the last one was compressed vertically. That was because it was being multiplied by a fraction. This is stretched vertically because it's being multiplied by an integer. It's also reflected across the x-axis. And it's also translated 1 unit to the right if we're going to compare it to the parent function. Now our domain is starting at 1 because we can't get below x's, square root of x is 0. So x has to be greater than or equal to 1. Our domain is going to be below the x-axis, so y has to be less than or equal to 0 as far as we can go. And that concludes lesson 10.1.